Hello, guys. My name is Sujoy, and welcome to this introductory course on applied statistics and probability. So, in this introductory video, what we'll be doing is we'll actually introduce uh, the field of statistics. So, what do we mean by statistics? And we'll talk about variables and attributes, and then we'll introduce what is a population, what is sample, and different ways of sampling your data. So here is the agenda of what we'll be covering in this video. So this is introduction to statistics, and so we'll be covering the meaning of statistics, then so what is data? Then variables and attributes, and population and sample. Okay, different ways of drawing samples from a population. So different sampling techniques. Okay, so this is the list of topics that we'll be covering in this introductory video. All right. Okay, so let's get started. So what is the meaning of statistics? Okay, so the term statistics is used in two different senses. So in the plural sense, it refers to a collection of numerical figures or data obtained from the fields of human activity, right? So you can write it down here. So in the plural sense, the term statistics refers to a collection of numerical figures or data obtained from the fields of human activity, and in the singular sense, it's basically the subject statistics, which is to imply the subject of scientific activity dealing with the theories and methods of collection, analysis, and interpretation of such data, right? So in the singular sense, the word statistics is used to imply the subject of scientific activity dealing with the theories, methods of collection, analysis, and interpretation of such data, right? Okay. So what are the characteristics and limitations of statistics? Okay, so let's try to understand that. So let's see. Characteristics. So first of all, typically all the available information on whatever topic we are dealing with. So the information are typically expressed in quantitative terms, right? So all available information are typically expressed in quantitative terms, right? Okay. Let's see. I actually put my whiteboard. So okay. All right. So that is the first characteristics, is that all the available information are typically expressed in quantitative terms in statistics. Then typically a statistics is basically some aggregate of facts, right? So it must be some aggregation of facts, and a single fact is of no interest to a statistician, right? So typically whatever subject we are studying, okay, so we are collecting some data on that particular subject, and then we are aggregating all the information, and then based on that aggregation we do some analysis on the data, and then we do some interpretation and make some decisions based on our analysis and interpretation, right? And so a single fact is of no interest to a statistician. So typically it must be aggregate of facts. So statistics must be aggregate of facts, right? So a single fact is of no interest to a statistician, right? And of course, it must be related to some field of inquiry, right? So it must be related to some field of inquiry, right? So for instance, let's say we want to find out the average rainfall, okay, in a city in a given year, let's say, okay? So that's basically, so we collect the rainfall information throughout the whole year, and then we can calculate the average rainfall, right? So this basically, it has to be related to some field of inquiry. And we can repeat the same process for subsequent years, or maybe for previous years as well, okay, to identify maybe the trend of rainfall in a given city. Okay. Then statistics should be capable of being related to each other so that some cause and effect relationship can be established, right? So exactly, this is what I was discussing, that like, let's say if we want to identify some trend in the data, right? So we might be able to identify some cause for which we are seeing or observing that particular trend in the data, right? And so you should write it down. Statistics should be capable of being related to each other so that some cause and effect relationship can be established, right? Okay. So that is one important point to mention, right? So another characteristic which is of importance is that okay, so statistics are typically affected by multiplicity of causes, right? So for instance, the observed data that we are getting is that could be a result of a large number of factors. So each of which contributes to the final figure that we are observing, right? So, and it is typically for the statistician to split up the effects due to the component factors and study them, right? So typically statistics are affected by multiplicity of causes, and whatever analysis we do, right, and based on in order to carry out that analysis, we have to compute, do some computation on some statistical quantity. And so whatever conclusion we make from that analysis, the exactness cannot be guaranteed, right? So for example, we took this example of rainfall, for instance, okay? So based on the rainfall, the average rainfall, maybe let's say that we compute for the past maybe 10 years or 15 years or so for a given city, let's say. Let's say we want to make a prediction of the the average rainfall for the next 5 years or so. Okay. And so this prediction cannot be 100% accurate. Okay. So this exactness cannot be guaranteed. Okay. So these are some of the characteristics of statistics. Okay. Now, there are certain limitations to statistics as well, and let's talk about that now. So, limitations. So, the first limitation is that statistics is applicable only to quantitative data and cannot be used to study events which cannot be expressed numerically. Okay. So, typically applicable only to quantitative data and cannot be used to study events that cannot be expressed numerically. So, for example, we can compute the average rainfall in a given city, right? But we cannot compute, let's say, the average intelligence of, let's say, maybe 100 people that we observe, maybe in random. Okay. So, because intelligence is basically it's a categorical data. Means we'll talk more about categorical data and numerical data subsequently. But I mean, you cannot. I mean, until and unless you assign some numbers to the level of intelligence of a person, you cannot compute the average intelligence of a number of persons, right? So the applicable, the statistics typically that we compute, we collect data and do analysis on those data. That is typically only for quantitative data on which we can apply statistics. And it cannot be used to study events which cannot be expressed numerically, right? So this is one limitation. Then, so the second limitation is that statistics can analyze only collective matters and not individual events, right? So typically we observe a set of we collect a set of observations, and based on that we do some analysis and make some conclusions or predictions, right? So we cannot make any prediction based on one single observation, right? So statistics can be used to analyze only collective matters, okay, and not individual events, right? Okay. Now, statistical decisions that we make based on our analysis of data and interpretation, that typically applies in the long run, right? And on an average, okay? So it cannot be precise. That's what we discussed earlier about the characteristics also. So statistical methods, or decisions rather, are applicable only on the average and in the long run, right? So if you compute, let's say you okay, so typically let's say we compute the we observe the data of, let's say, how many cars, let's say, pass through a bridge in a given day, right? Okay. So we collect data for that over a period of time, right? And then we compute the average, right? And then we observe. So for a given day, now on a particular day, the figure that we obtain, that is typically that might be different from the average value that we have computed, right? So typically the figure that we observe will not be precise to what the average value is, but typically the average means that is the expected value of the number of vehicles that are passing through that particular bridge that are typically expected to pass through the particular bridge on a given day. So that's basically what we mean by these particular limitations, is that the decisions are applicable only on the average and in the long run. Okay. And so the statistical methods, if not applied in the proper perspective of the collected data, may lead to false conclusions. So we have to be very careful about how we should apply the data that we collect and analyze, right? So statistical methods, if not applied in the proper perspective of the collected data, may lead to false conclusions, right? And the next limitation is that statistical data must be uniform. That means, so the underlying causes or the environment or the scenario that we're considering, under which we are collecting information on the given subject, that should not change, right? That means the factors that are influencing the data that we are collecting, they should stay unchanged. Okay. So statistical data must be uniform in the sense that they should be subject to a stable causal system. All right. Okay. So I hope it makes sense so far. So I think we are done with the meaning of statistics. All right. Okay. So let's mark that as completed. Okay. So the next topic will be so what is data, right? So let's talk about what is data. All right. So what is data? So data means any collection of numbers, characters, images, or any other items that provide information about something, right? That is what we mean by data, right? So let's write down the definition here. So any collection of numbers, right? Characters, images, or other items that provide information about something, right? So that is what we mean by data. Yeah. Now, data. So when we collect data, it can be from a population or it can also be from a sample, right? So we'll talk more about that. So data may come from a population or from a sample, right? So population means the entire set or collection of entities that we are studying, right? So we'll introduce a more formal definition subsequently. But in statistics, a population can be defined as a collection of persons, things, or objects under study, right? Now, if the population is very large, then it might not be feasible or practical to collect data from every single entity in that population, and which is why we often draw samples that are representative of the population, okay? So to study a large population, we draw random samples from the population, right? And we assume that the characteristics of the sample is likely to somewhat represent the characteristics of the population, right? So characteristics of the sample is likely to somewhat represent the characteristics of the population, right? Okay. So now the question is, what is it that we do with data, right? So we collect data from either a population or maybe we draw a sample from the population and then we collect data from the sample, right? So the question is, what do we do with the data, right? So what do we do with the data that we collect, right? So what we do is we collect the data and then we analyze and summarize, right? And then we interpret the data, right? Now, based on our interpretation of the data, we make some decisions, right? So that decision could be making some predictions of the quantity that we are observing, or the trend, to predict some trend based on the analysis on a certain topic, on a certain subject, okay? So if we don't make any decision, or based on our analysis, if we don't make any decision or any interpretation of the data, then the collection of data is useless, right? It's of no use to us. So what we typically do with data is that we collect data first, right? Then we analyze, then summarize and interpret the data, and then make some decisions or some conclusions, right? It could be the case that we collect data and then we identify some patterns or trends in the data, right? Which is not always obvious from the raw figures that we collect on a certain object or on a certain topic or on whatever, like on a study. Okay. So we collect, analyze, summarize, and interpret the data and make some decisions based on our interpretation of the data, right? So if we are not able to make any decisions or interpretation of the data, then the data collected is of no use to us, right? So these are the activities that we typically do with the data. So we first collect the data, then we analyze the data and summarize. So summarize means we have to represent the data in a proper way, right? And then we have to, if it is some quantitative value, then we compute different statistical quantities from the data. And then based on that, we make some interpretations of the data, right? And some decisions we can make based on our analysis and interpretation of the data. And so statistics is the subject of collection, organization, analysis, and interpretation of data. And so the collected data, as I just mentioned, is that the collected data is of no value unless we can use it to make some decisions, right? Okay, so that's the basic purpose of collecting the data, right? So we collect, analyze, and summarize, and then we have to do the interpretation of the data based on our analysis. And then based on that, you have to make some decisions or draw some conclusions, okay? All right. So let's see. So we are done with what is data. Now let's talk about types of data, all right? So I think we can mark that as complete. So let's talk about different types of data, right? So types of data, and long story made short. So we typically have two types of data, right? So either it can be quantitative data or it can be qualitative data, right? So So data can be qualitative or quantitative, right? So what is qualitative data? So qualitative, or this is also known as categorical data, means data that is non-numeric, right? So data that is non-numeric and which is typically the result of categorizing or describing the attributes of a population, right? So, for example, hair color of a group of people that we observed, or let's say the blood group, right? Or ethnicity, right? Etc. Right? And then, of course, we have the quantitative data, right? And so this is basically numerical data, which is typically the result of, let's say, counting or measuring some attributes of a population, right? Which to which we can have some numerical figures, right? So numeric data typically result of counting or measuring attributes of a population. For example, height, let's say, or weight, or number of people in a city, etc. Okay. Now, for quantitative data, it has to be noted that so for quantitative data, the mathematical operation is meaningful, right? So if it is not a quantitative data, then we cannot have any mathematical or any meaningful operation, uh, any meaningful mathematical operation on data. So, for example, why I'm saying this, it's because let's say we have we collect zip codes, let's say, okay. Now, zip codes typically we have numbers, right? But we cannot add or subtract two zip codes to get a third zip code, right? Okay, so that's addition or subtraction of zip codes has no meaning because this is not a quantitative data, it's categorical data or qualitative data, right? So for qualitative data, any mathematical operation is meaningless, right? So another example is, for example, phone number, right? So zip code, phone number, etc. are examples of qualitative data. Okay. All right. Okay. So mathematical operations are meaningful only for quantitative data, right? So let's talk about quantitative data now. So quantitative data can be of two types. So data can be either discrete or continuous, right? So let's talk about these two types of quantitative data now, all right? So first is discrete data. So discrete data means that can take only certain numerical values, right? So for example, number of phone calls received in a day, right? So we have, so these are countable values rather, okay? So data that can take only certain numerical values are discrete data. Okay, so for example, number of phone calls received in a day. Let's say number of children in a family, etc. Right? And then of course we have continuous data. So continuous data means that data can take any value within a predefined interval, right? So data that can take any value within a predefined interval. So for example, temperature, right? So temperature, it can theoretically take any value, like it can have an infinite number of observation values. For example, if we measure temperature in, let's say, Fahrenheit, so let's say, if we measure the temperature, we get the value 72 degree Fahrenheit, then it can also take values like 72 point, let's say 72.01 or 72.001 or 72.0001, right? So depending upon the precision of the measuring instrument, we can measure temperature with a certain precision, right? So theoretically, it can have an infinite number of values in a given interval, right? So, for example, the angle measured in radians, let's say. Okay. So let's say temperature, height is also an example, weight, so angle measured in radians, etc. These are all examples of continuous data, right? Okay. Now let's talk about variables and attributes. Okay. So typically, the statistical information that we collect from a group of individual or objects can be of two types. Again, like these are already we discussed. These are qualitative data or quantitative data. Now, typically variables, we denote variables. We use the term variables to represent quantitative data. Okay. So in statistics, a variable is a quantitative character of an individual or item that can be measured or observed, and that can take on different values, right? So this is basically the quantitative data that we have discussed, what the term variable is used for. Okay. And so variables, typically in statistics, we use the term random variable more often than just variable, right? And it can take various different values at different points of time, which is why it's a variable and not a constant, right? Now, the other term that we want to use is attribute, okay? And so attributes are basically the qualitative data or the categorical data. So an attribute is qualitative or rather qualitative character, I should say, of an individual or item that cannot be measured but can only be classified under different heads or categories. Okay. And this is what we mean by qualitative or categorical data. Okay, so this refers to qualitative or categorical data. All right. Okay. So now let's talk about now depending upon the source of data, data can be classified in two different categories. One is what we call the primary data, and the other is secondary data. Okay, so classification of data based on the source. So we have two types of data. So here so one is primary data. So primary data means data that is directly collected from the field of inquiry, right, for a given purpose. So data that are collected directly from the field of inquiry, right? For a specific purpose. And hence is original in nature, right? So when we directly collect the data from the field of inquiry for a given purpose, that is primary data, right? Whereas for a certain purpose, if we collect the data that is already collected for a different purpose previously, then that is secondary data for us, for our purpose, right? So primary data means if the investigator, they collect themselves the data that is of interest to them for the given scenario, then that is primary data. Whereas if the investigator uses data collected by others that were initially collected for a different purpose, then that is secondary data to the investigator. But that could be that is the primary data for the previous purpose for which it was collected. But for the investigator, when he or she is using the data that was already collected before for a different purpose, then that data is secondary to that investigator. So secondary data means data which have been previously collected by some entity and used by another, or collected for one purpose but used for another purpose are secondary data. Okay. So the characteristics of primary data are typically that it usually show detailed information, right? And a description regarding the definition of the terms used, right? And how the data was collected and whether, so the method of collection, as well as if there are some approximations that were used in the collection of data, right? And this helps in deciding how much reliance can be put on the data, right, for the given purpose, right? Now, collection of primary data is costly, which is why very often we might need to use secondary data, okay? So the characteristics of secondary data is that it is usually it might contain errors due to transcription as well as due to approximations or rounding, etc., right? And so secondary data is less reliable than the primary data, right? So for a given purpose, when the investigator collects the data themselves, then they will be careful about how the data will be collected, should be collected for the given scenario, right? But when we use data collected by others, they originally collected it for their use, and so the way they collected the data might not be suitable for my use, right? So typically the secondary data contain errors due to transcription or rounding, etc., or so hence it's less reliable than primary data. But very often we have to use secondary data because it due to like time constraints or budget constraints, right? So when the investigator due to lack of time or maybe due to lack of financial resources, it might not be possible for the investigator to collect primary data. Okay, so in that case, in such situations, they use secondary data. But in some other situations also, like for instance, for comparing data collected over a period of time, secondary data is used, right? And also, like when in scenarios where utmost accuracy is not very important, like we afford to have some sort of like some error is okay. So if that is the case for the scenario under consideration, then we might want to use secondary data, right? Because it's cheaper and it's of course readily available, and so it doesn't require much time uh, to gather the data. And yeah, so that's what it is. Okay. All right. So now, what do we mean by, so when we collect data, so what do we do after? So typically one data that we collect is what we call an observation, right? Now, we have to define the term observation versus what we call an experiment, okay? So what do we mean by observation? And what do we mean by experiment? So observation means that it measures specific traits, right? But doesn't modify the subjects, right? So typically, so we measure some values or some specific traits, but in that process, the object, the subject is not modified in any way, right? So observation measures specific traits but doesn't modify subjects, right? So for example, polling or survey, right? Or whatever, like if you collect information from a group of people, like it could be you measure some attributes or some characteristics or some, let's say we collect the height of individuals in a group, right? Or let's say we survey some students to seek the opinion on what is the most difficult subject that they feel to grasp. Okay, so these are all observation, right? In the sense that it doesn't modify the subjects, right? Whereas for an experiment, we typically, the process of an experiment modifies the subject, right? So experiment means it applies a treatment and then measures the effect on the subjects, okay? So for example, when we test a vaccine, right, we apply the vaccine on some subject, which is typically on some human body, right? Like so for different such testings, typically some volunteers, sometimes volunteers are hired, or even those who are hired, they're actually paid for being the subjects of those experiments, okay? So for example, testing a vaccine, right? So if you're not modifying the subjects, it's an observation, but if you're modifying your subjects, then it is an experiment, all right? Okay. So now let's formally introduce the terms population and samples. So population means the complete set of elements being studied. Okay. So the entire set of objects or elements that we are studying, that is basically what we mean by the term population. However, it is not always feasible for us to collect data for every element in the population, which is why we often need to draw samples, which is basically a subset of elements from the population. Okay, so a sample is a subset that is drawn at random. This is very important. Okay, so the sample needs to be drawn at random from the population so that there is no bias, or so that actually um, it's a proper representative of the population. We have to ensure that, and which is why it is typically drawn at random. Okay. Whereas if we collect the data from every single member of the population, that is called a census. Okay. So census means collecting data from every member of the population. All right. Okay. So what do we do when we collect this sample? So our goal is to measure some feature or some characteristic of the population, right? So it could be, for instance, the average rainfall in a given year in a particular city, or it could be the, let's say, the average height of individuals in a group of people, let's say, right? Or let's say the average number of hours per week uh, that students study in a particular institution. Okay, it could be um, um, any scenario that we might want to consider. Okay, and so what we are measuring is basically, what for the population is what we call a parameter of the population. Okay, so the parameter that we um, want to measure is basically a characteristic of the population. Okay, so this is some characteristic of a population that we want to measure. This is called parameter of the population. But when we want to estimate that parameter based on a sample, so what we compute from the sample is what we call a statistic. Okay, so statistic is basically some characteristic of a sample. Okay, so we want to estimate the parameter by computing the statistic, because very often it is the case that we cannot collect data from every individual from the population, which is why we always we in many situations, in most of the situations, we draw samples that we assume to be representative of the population, and so the quantity that we compute from the sample is what we call statistic, and by computing the statistic we try to estimate the parameter of the population. All right. Okay, so let's see, let's come back to our topics, and I think we are left with only one more topic, which is basically different sampling techniques, right? So let's talk about that now. So as I mentioned earlier, that samples need to be drawn randomly, right? So that there is no bias in the sample. So we talk about random sampling, okay? So there are different ways of drawing samples. So what do we mean by a random sample? Let's talk about that first, okay? So random sample, so a random sample refers to a sample where each member of the population has an equal chance of being selected in this sample, right? That means we draw samples at random means that every individual in the population has an equal probability or chance of being selected, okay? That's what we mean by a random sample. Now, there are typically four common sampling techniques, okay? So that would be the, okay. So four common sampling techniques. So the first is what we call convenience sampling, okay? So number one is convenience sampling. So convenience sampling means that we draw samples that are readily available, right? So for example, data collected from a specific group that is easily accessible, right? So for example, let's say you want to observe, or maybe you want to know that what is the most popular movie that is currently being played on the theater halls. And to in order to have an idea of that, you survey your friends, let's say, or the people whom you know well, okay, and you just choose a few people from your maybe from your friend circle or from the people whom you interact more, so that you can have, so which are the people who are easily accessible to you, and you collect the data from them, okay, and based on that you uh, do some analysis, and then you draw some conclusion that okay, um, yeah, so that's basically what we mean by convenience sample. So this refers to samples that are easily available. So for example, data collected from a specific group that is easily accessible, okay? And so since you are actually choosing the people from which you might want to draw the sample, it's not entirely random, right? And so in that sense, it has bias in it, okay? So data based on convenience sampling is not likely to be random, right? Okay, and what is the advantage of convenience sampling? It's easy to obtain. Like, I mean, it's easy to collect, right? Because it's very easily accessible, right? But the problem with that is it's not entirely random, right? So the result based on convenience sampling um, is not very reliable, right? Because it will have bias in it in most of the situations. Okay. Then we have systematic sampling. Systematic sampling. Okay. And so what is systematic sampling? So we put a population in order and then select every kth member starting at a random spot in the list. Okay. So we put the population in order and then we start from a random position, and from that position we select every kth member. Now the value of k might also vary, okay, and depending upon your application, or you have to it's a design choice that you have to make, right? So for your application you might try out different values of k, and yeah, and then you have to, and you might want to repeat starting at different positions in the list. Okay, so this is what we mean by systematic sampling. Now the third type of sampling is what we call stratified sampling. So for stratified sampling, you have to break the population into subgroups based on certain characteristics, right? And then you have to sample each subgroup. Now, when you might want to do stratified sampling is when you want to ensure that you have at least one representative from each of those subgroups based on your the criteria that you have identified to classify the population into those subgroups, right? So break the population into subgroups based on some characteristics and then sample each subgroup. Okay. Right. So that is stratified sampling. You break the entire population into different subgroups based on certain characteristics, and then you sample each subgroup. Okay. So that you have at least one representative from each of those subgroups in your sample. And then the fourth or the final type of sampling is what we call clustered sampling. Okay, so what we do in clustered sampling is we divide the entire population into groups or clusters regardless of any characteristics. Okay, and then we randomly select a certain number of clusters. Okay, and for those selected clusters we take every individual or every observation from those clusters. So divide the population into groups or clusters. This is regardless of any characteristics. then randomly select a certain number of clusters and then collect data from entire cluster for each of the selected clusters. Okay. So that is what we mean by clustered sampling. All right. So I think with that, we should conclude our discussion on this introductory video. So what we have discussed in this video is we have introduced the notion of statistics. So in plural sense, it refers to a collection of numerical figures, and in singular sense, it refers to the subject statistics, that is the subject of scientific activity dealing with the theories, methods of collection, analysis, and interpretation of such data. And then we introduced the notion of variables and attributes and different types of data. Then we talked about what is population, what is sample, and then we introduced different types of sampling techniques that are typically followed in typical scenarios. Okay, so that's pretty much all I had for this introductory video. And so I'll see you guys in the next video. Thanks for watching.